Picture this. You're out for lunch with your hipster friends who want to do nothing but talk about the environment. They've been buying at Bulk Barn with your mason jars, using hemp baskets for shopping, walking everywhere, and talking about their vegan diets while you're in debt from student loans, wishing you could just save enough money for your electricity bills and be as environmentally friendly as they are without putting in as much effort. If you've ever wondered where your excrement goes, or even wondered and wished you could produce energy from just sitting on a throne all day, I have a solution to your problems. My name is Fernandes. I'm a fourth-year civil engineering student, and I will be talking to you about microbial fuel cells, or MFCs, as a source of energy I'd like to call Stinkies to Sparks. Before I explain this technology as a source of energy, I'd like to give you a background on what MFCs really are. In a nutshell, an MFC converts chemical energy to electrical energy with the use of microorganisms. More specifically, it is bioelectric chemical system that is a technology that is commonly used for sustainable wastewater treatment and resource recovery, but can also be used to harvest energy. Even more specifically, bioanode sensors are analytical tools that use exoelectrogenic bacteria to oxidize organic material and generate measurable electrical signals through the transfer of electrons to a bioanode. To harvest energy, these bioanode sensors can be operated as MFCs, where the bioanode reaction and other reactions that are held at the cathode and electrode are driven spontaneously to create electric power. A variant of this technology, known as microbial electrolysis cells, or MECs, is also used to monitor microorganisms, and the same bacteria strains of Geobacter and Schmonella are observed. Now, what I am proposing is a small-scaled, residential-based use of this technology with a feed of wastewater that is produced directly from the residential bathroom use. As wastewater is experimentally taken as sludge and other effluent from wastewater treatment centers, the supply of energy that will be used for this technology would be coming directly from the bathroom and will be able to supply electricity for the whole household in the form of lighting. Hence the term Stinkies to Sparks. So essentially, the energy for lighting will come from the transfer of electrons in the MFC, which will be fueled by the bacteria, which will be fed by wastewater that comes directly from the house, or in this case, you. The use of MFCs for electricity isn't so far of a stretch. MFCs have been used before, and as early as 1931, a rendition was capable of producing, say, around 35 volts with a small current of only 2 milliamps. It has thus evolved to the point where 10 liters of brewery wastewater was converted to carbon dioxide, clean water, and electricity only a decade ago. Doing the math, if we're using direct current, a typical fluorescent light bulb would need only 15 watts of energy and of power, which with a 2 milliamp supply of current would mean 7,500 volts need to be produced to generate enough energy. I'm currently running an MEC as a research component, which can produce up to 2 volts. It only requires 15 milliliters of wastewater and to be fed twice a month. Several of these small MECs could be put together and produce well over the required amount of energy to fuel several light bulbs. Other than by just saving money on your electricity bill, finding a way of being satisfied and contributing to a greener society by just sitting, and answering some of life's greatest questions. Why would you want this technology in your house? The size of these MECs are small enough to fit in the size of your hand, so fitting this in the bathroom would be next to no problem to hide it away, but not so microscopic enough not to see it if you wanted to have it as a feature piece in your bathroom. Personalize your bathroom while being green and make your hipster friends jealous. This household MEC has a large-scale potential, as all homeowners are potential clients. Homeowners are always looking for ways to save money, and this could be a great way to both save money and be green. Canada by itself has 13 million households, which would mean 13 million potential clients. There are currently no available household MECs on the market, meaning we would be the only product on the shelves. Other than composting, there really would be no other competitors on the market. I truly see the potential of this energy source and innovation to be used, albeit with a more appropriate name, it could be further commercialized. Thank you for listening.